Hi, lesson 5 of schematic and PCB design course. This week we are going to speak about BOMs and variants, and watch very carefully because this is going to save you a lot of time. First we will speak what is it all about and how it is going to save your time. As an example, I will use this Voipack module, SOD module, and as you can see, they have 3 different variants. This is what's happening also with your products. It is exactly same. You design one schematic, one PCB, and it may be used to build more variants of your product. The difference between variants is in the components, basically. For example, if you have a look on this SOD module basic, yeah, there is no 3D accelerometer, there is no micro SD socket, there is no SPI flash I2C EEPROM. Yeah, you can see the difference. So some of the components are not fitted on this board, but it is exactly same board, like this one and like this one. Same schematic, same board. Also, they have different processors, for example. 101 gig, 1.2. They have different memories. 512, 256, 128. What's normally happening, and what I used to do before, I created the schematic, the board, and then I generated the BOMs from this, the BOM from this schematic and I manually created all these 3 variants. So I went through the full BOM and I removed the unfitted components, or I replaced, for example, the processor for different processors. It is okay for when you are creating the first product. You will not see big difference of using variants or not. When it is going to be important is later. That's the time when it will be much more visible how you can save your time. What normally happens after, I don't know, for example, 1 year of having your product on the market, there is a component which is end of life, so you have to replace it in schematic. You simply replace it in the schematic. It takes a few minutes. You make the changes in the PCB, few hours maybe, and then what you have to do, you have to generate the BOMs again. And it's not only BOMs, because you have to generate 3 BOMs, you have to generate also 3 different documents for a company which assembles the board. 3 different assembly drawings, yeah, 3 different pick and place files. And just doing all this component management from the BOMs and generating all the documents may take much longer than actually doing the changes. And it actually takes quite a lot of time. Not saying if it's done manually, you can do mistake. Very easily you can do mistake, because don't forget, it's been like a year, for example. So you may not remember everything, why you fitted this component. So you can very easily make mistake when you will be removing some components for particular variant, or you can just make mistake in the BOM if you have to make the BOM manually. And what really can happen, I saw it, this really happened. If there is a mistake, like for example they fit 100 nanofarads instead of 10 picofarads, board may not work. and you need to spend maybe weeks of trying to find what's the problem, what's wrong, only because of the wrong BOM. So eliminate all these things. You can configure your schematic to do it, just press few clicks automatically. And there is one more thing. Oh, this is even much more difficult. Imagine you have a co-worker who left the company and you need to take a project, make some changes, what he was doing. You actually may have no idea about the product, what he was developing, and you need to generate the BOMs and manufacturing information from the board. You actually have no idea what is it all about. Imagine how much time you can spend with doing this, but you can configure it in Altium and simply press few clicks, generate it automatically. I will show you now how many engineers generate a BOM. I was doing it exactly same way when I was starting with hardware design, so it's normal, don't worry if you do it this way. You remember, we had the components with no parameters in the schematic, but we still have there the special one, which I put there during our lesson. So we have one component with parameters, and I will show you how we can then use them. First, when we go to generate the BOMs, we need to go right click, add new to project, and we will need to add output job file. This is actually the place where you save the kind of instructions how the output from your Altium project should look. So you set it here once properly, and then when you need to regenerate the outputs, you simply just press generate and that's it. So you don't have to set up then more times, and it's very easy way to do it multiple times later when you have new versions of your board, for example. We are going to add new BOM, and I will configure it first, so you will see what information we have available from the Wojpak schematic. I will just move it here and order it. Okay. Now we have the information about the component. I don't want to have there this description, so I just remove it. And I don't want to have there this libref. I will remove it. Okay. Here I will explain later what this means. We can now generate BOM from this. And have a look. This is the kind of output what I got before, a long time ago, when I was starting with hardware design. And the next step is you order it by yourself, or you fill here the part numbers and you send it to someone to order it, because in your company usually you have a guy or you have a girl who is just ordering the components for you, and that's really standard. You have someone else who is ordering the components. So what is happening? If engineers are too lazy, they don't even specify part numbers for components like capacitors or resistors, because they think it's clear from here, yeah, I want 1 microfarad 0603, yeah, so buy some. By the way, this is not full specification of the capacitor. Yeah, there should be also voltage, and there should be also some properties like, is it NPO, is it X5R, or it's not so simple. So what happened then? When you ask someone to do it, they will ask you question back. Can we order this capacitor? Is it the right one? What do you need? You need to go back to your schematic and have a look if the 50-volt capacitor is the right one. And then you need to say back, yes, it is the right one. Or you can fill it by yourself. It takes a lot of time. What is happening a lot? Many times the engineers even don't specify the exact part number for chips. That's not good. Why? Because you send this kind of bomb to the girl, and what she has to do is she will find, for example, this one, SI4705, and based on the footprint she will try to build the exact part number. Sometimes happen they make mistake, and then you buy 1,000 components in wrong footprint. This is really happening. I saw it many times. Wasted money. You have to order it again. So the best is if designer specified one's exact part number and say buy it here, exactly this component. It helps a lot. Another example. When you don't specify it, the girl, she sent an email to one of 10, 15, 20 suppliers and asked them to supply a chip. And the supplier, they say, we don't have exactly this number, but we have this one. Is it the correct one? Do you want to buy this one? So he sent the email to the girl, and the girl will forward the email to you and ask, please check if we can order this component. You have to interrupt your work, stop doing everything what you were doing. You have to open the datasheet, go back to this old schematic, check if it's the right component, and you have to answer yes, no. Wasted time, wasted time. It may not be visible, but if you have more projects and from each project you are receiving this kind of questions, what may happen very soon is you are not working on the design where you need to focus and work full time. You are interrupted continuously with these kind of questions which you have to answer. So I hope you now see the benefits of creating the proper components with all the ordering information, because when I go back to our BOM, I will now show you how simply you can show the information from the DigiKey which we imported. Here is the table with all the parameters from the DigiKey. And what we are interested to see is the manufacturer part number, supplier 1 and supplier part number 1. So I just find it here. Manufacturer part number, supplier part number. See, they are here. Now when you generate the BOM, Imagine you have done it for all the components. See how different it is. It's taking some time. Yeah, these are the resistors which we use. Oops, this is the buffer. Imagine you have all the components with this information. You have everything is done. You don't have to do anything. You just send this to the girl. She go to DigiKey and order this part number. No questions. You just saved a lot of time. Biggest advantage is, as I said, once you create this component, it's done. You can use it as many times as you want in future without spending minute filling this information on or answering the questions. You got it, yeah? Now I will show you a little bit more complicated project. So how we can generate a little bit better BOMs. Before we go further, I have to say, even if you work alone or if you are ordering components by yourself, it's important you do it properly, because you don't have to waste your time with all the component management. You don't have time for this. Your time, what you should be doing is focus on schematic and PCB design. So component management must be done for you as simple and as fast as possible. And that's the way what we are speaking about now. We will take a little bit break now and we will speak about environmental chamber testing. It looks like this. It's a machine where you place your product, your board, and you can run it in different temperatures, different humidity. Why it is important to do this kind of test? Because if there is a weak point on your board, you will find it. If there is a component or something what is running just on the edge, you will find it. In the chamber you will find the kind of problems which you may never find on your table in the lab, but your customers may find them, because everything may look okay on your table. You send it to customers, they place it somewhere where it's too cold or too hot, and the board starts failing. This really may happen. So to prevent this kind of situation and to be sure your board is really immune and it's running properly and it's good, use the test in environmental chamber. How to do it? Prepare a simple functional test. So you are just testing in loop all the peripherals what are on your board. For example, for serial port, just send something out, use a loop back and receive it and check if it's same. For SD card, read and write, yeah, and check if it's same. For hard drive, same. It's, you got it. You need to have the production test anyway, so it's basically very similar. And don't place the hard drive or this kind of thing into the chamber. Place it outside the chamber, because you don't know then if the hard drive fails or your board fails. What is important? Run this test for a couple of days, whole setup on your table in your lab, and be sure there are no errors before you place it into the chamber. When I was starting, or when I was doing my first test in the chamber, I made a mistake. I measured the board, I took it, placed it into the chamber, and I started running the test. Of course, the board failed, so I had to open the chamber. I had to check what gets wrong, maybe fix it, close the chamber, start the test again. It failed again, and you can't debug the board in the chamber, or you can, but it's difficult because, for example, when the chamber is running at -40, you should not open the door at -40, or you can open it, but what will happen then is and there will be snow everywhere in the chamber. It will start melting. There will be mess. You have to clean it, and you should not open it at -40. So if your board failed at -40, doesn't want to start, you should set the new temperature, wait half an hour or 1 hour, and then open the chamber. It would take ages to debug your board in the chamber. It's not good. So always be sure it's running without error for a couple of days on your table. What I also do in the chamber, I run the functional test, and then at -40 I normally also try switch on, switch off test. It means I leave the board cool down, switched off, because the components are hot or warm when the board is running. So I disconnect power, it cools down, and I try to switch it on and see if the board boots up. What may happen, I've seen this, what may happen, some crystals, for example, may not start oscillating in the low temperature, so the board fails. What I also seen was failing memory at certain temperature. Memory read write start failing. This is kind of a problem which you may never find on your table because it's not visible, but in the chamber you can easily repeat it and fix it. Then what I do, I measure the top temperature. It's usually when one of the components gets too hot and the board fails, it switches off or it freezes. So it's important also to know the top temperature when your board may be working. It's not expensive. I was doing this kind of test just a few weeks ago. In Slovakia it costed 3 euros per hour, so it is worth it. And when you finish this test, you may be pretty sure your board is strong and good and immune for this kind of things. So we know how to generate the simple BOM, and now we are going to generate the BOM which has all the information, which is completely automatic filled in, and which you just can take, send it to your purchasing department, and they can order all the components without asking you any questions. For the demonstration, I will need a schematic which has all the components with the parameters. So I can use this VoIPAG. I will use this one, and the client agreed to use it in this video. Before I show you the BOM, the full BOM, I will also mention 2 other kind of BOMs what I normally use. First one is these component references. What do you think, how it is used and when, and how it looks? This is pretty simple BOM. It looks like this, and it is actually used by assembly company when they need to know, for example, what is C22 capacitor. They check it here. and fill the machine. The other BOM, what is here, it's this one, library check. Looks like this. Usually when I start creating the components, only this one is filled in. And in this BOM I can check if I created footprint for the schematic symbol. These are schematic symbols. So if this is empty, there is no footprint existing for this schematic symbol, so I have to create it. And you remember these parameters. You can see next week we will be speaking about checking schematic and footprints. Here I can easily see if for example the component is safe to use, if it was used on some other design, or if it was checked before. So if this is empty, I have to check this symbol, I have to check this footprint. From this simple BOM I know which components need some additional care. Finally, to this one, I'm not going to do this. We would need to wait like 5 minutes. So I took screenshot. Looks like this. This is exactly what will open when you try to configure it. We group the components by libref. Libref is actually manufacturing part number. So by doing this, all the components which have same manufacturing part number are grouped together, and the quantity change based on how many components have same part number. Here you know this. You select what you need to have here. And these columns are actually the columns which we want to have in our BOM when we generate it. Here I set template which is going to be used. I will show you how you can customize the template. And this may not be visible. Oops. Here you can set the currency, and in this corner you can set quantity for how many boards you are going to build. So for how many boards this BOM is going to be generated. It means if you need, for example, 2 components per board, and you put here 1000, so in total you will need 2000 components, yeah? And based on this number 2000, the price from the supplier will be used. That's important because I normally use 1000 because these prices are then the prices, the kind of real prices, the reference prices. If I generate this BOM just for one piece of board, this price may be like 2 or 3 times more expensive, not real price. And the cost of your board may be unrealistic, you know, because build one piece of board, it's much more expensive than when you are building 100 or 1000. So I use 1000 as a reference price always. Then you just press OK when you close it, and when you generate, okay, again I'm not going to do it, it would take another 5 minutes, you will get our BOM. See, everything filled in. And actually this information, supplier stock and price, is checked from the database of the suppliers based on the number of components you need. And it's real time, it's done at the moment when you are generating the BOM. So the prices are real prices. When you now order the components, it will cost you, say, $142 per board when you order 1,000 boards. Very useful, because even at this stage you only have schematic, yeah, and even at this stage your boss, your client, will know quite accurate how much the board will cost. It's important because they need to tell it to the sales department, and they need to check actually if your new product will be competitive with the products that are on the market, you know, if the price is not too high. And if it is, you still can go back to your schematic and edit or remove some very expensive parts from your board, so you can optimize the total price of the board. Very useful. At this stage you know quite accurate price of your board. How you customize this template? That's very simple. I actually place the template to the lesson 5 course design files, all tune specific files, all tune templates. You can find it here. When you open it, looks like this. Doesn't need explanation. When you have a look on the parameters, on the component parameters here, oops, like here, you can easily see the column names are actually the parameters. And you can use this template. It will work with DigiKey components. You just can change your logo, company name, website, and maybe fill these parameters in your design. You know now how to generate perfect BOM from whole components in your schematic. But that's not enough, because even if you generate this nice BOM from whole schematic, you still would have to manually remove some unfitted components. This can be done automatically too. So how you create the variant for this module, for this module, for this module, you know, how to tell I won't use this processor, this one, and I don't want to fit these components. There is variant manager. Can you see top right corner? There is a button. I click there. It's a little bit slow. And I will create new variant, for example, prototype. As you can see here down, all the components are fitted for the prototype at the moment. So we are going to configure it. You have more options how to configure or where to configure the variant. The visual way is doing it this way. Maybe you never spotted, on the bottom of the schematic there are two tabs. Now I will click on the second one. I go to the variant manager and I select our prototype variant. You can see it. Can you follow it? Okay. And now a button appears here. When I click on this button, I can visually go find the component which I doesn't want to have fitted. For example, this one which I selected previously with this text, and if I don't want to have it fitted in prototype, so I just click there. You can see it's taking quite a lot of time to do it. So if you need to unfit whole page, for example, because you may have one peripheral on one page, for example Ethernet, you don't want to fit it for particular variant, you can do it simply. Just go to the editor and you can select the components. Press right click, part actions, variants. Now only these selected components you will see. Here are only the selected components. You select them all, right click, set selected as not fitted, press OK. Now I go back. Here, see? In one step you can unfit more components. If you need a component to be fitted but different, for example, different processor, different memory, you can double click and here is the new value. So I just go to a library and let's say it will be called by full name, yeah, in this new variant, but you can use completely different component. Have a look here. See, it's called like this. Now I switch to no variants. See, it's the name what was there before and everything is fitted. You can create any number of variants you need. And always when you switch here between variants, the components will fit, unfit and rename for the particular variant. How this is going to be used in the BOMs. I will show you very simply. I will generate or I will create a simple BOM with all the components on each component per line. So I will move this here. Oops. Okay, they are now grouped, so I remove the groups. Just click and drag it down. Okay, you see now we have each component per line and they are ordered by designator. So I go down and I know I unfitted this U question mark in our schematic. You remember that. When you press right click, change variant, go to prototype, see what will happen. It will not be there. See, there is no U question mark now because it's not fitted for this variant, so it is not in the BOM. Okay, you see it here. Here on the top of the job file, you can select the variant. So it may apply for all the documents here, because the variants may apply on schematic. When you print schematic and use variant, you will see in the schematic all the components which are not fitted. We will speak about this later when we will be speaking about generating documents for your project. Same for assembly drawing. When you select the variant in the assembly drawing, you will see what components are fitted and what are not fitted. Very useful for the assembly company because they can clearly see what components are not fitted and visually compare if the board is fitted exactly the way as you draw on your assembly drawing. Okay, I will generate the BOM for prototype. Yeah, see, you will see in the BOM there will be no U question mark. It's not difficult, it will help a lot. Everything is automatic. So once you set it properly, you don't have to do it again. Okay, here is the BOM. See, there is no U question mark. I will go back to Altium I will change this. I will generate the document again. There will be U question mark. If you set this properly in the first time, after 1 year, you don't need to remember anything. It will work. See, here is your question mark. If someone else set their project properly and he leave the company, you can go back, use his Altium designer file and generate it without knowing details about the schematic. It's very quick, so when you need to release new version or new issue of your board, you just select variants, generate all the documents, and no manual editing, no errors when you create the BOM. I'm sure you understand the benefits of using this. This is all great, yeah? But there are some components which you don't want to have in BOM, but you want to have them in schematic. For example, mounting holes, yeah? This is typical component which is only in the PCB. On the other side, there are components which you would like to have in your BOM. You don't want to have them in PCB. For example, PCB. Because, as I mentioned before, when you generate the BOM, there must be everything. So the purchasing department, they order everything what you need to build the board, including PCB. So it should be in the BOM. What will happen now? And what is different? Different is this. When you create component which you don't want to have in the BOM, select the type to no BOM. If you won't have a schematic symbol or component which is only in the BOM, not in the PCB, select the type to mechanical. What will happen? See, here are mounting holes, MH and PCB, PCB question mark. So we go to our BOM and we generate it again. We will be looking for MH and we will be looking for PCB. Okay, so here is the PCB. There is no MH. Perfect. And I told you we will speak about the schematic generated with variant and the assembly drawing with variant. I'll show you how it looks. Can you see? This is how unfitted components are marked in your assembly drawing. So all these red components are not fitted. For the schematic, it looks like this. All these gray components are not fitted. Automatically, when you print the schematic and select the variant, automatically they are gray. Automatically they are red. Very useful. Bonus time. And today about memories again, because I received a lot of feedback or questions about high-speed design. So let's have a look on simulation of the memory. I just will speak very briefly about that because I don't actually have the software to simulate memories, but some of my clients, they have them, so I do it sometimes. And I have some pictures, some screenshots from the simulation what I've done. But before we go there, let's pick what is so different about simulating memories and what is important. To simulate memory, it's not so simple, because memories, they have, it's called on-die termination, ODT. I'm sure you know that. And it's actually something, it's you have the resistors, termination resistors, placed on the chip itself, on each of the data lines and some other signals, and these termination can be switched on or switched off and can have different values. What are the values what you can have? Where is my data sheet? It's here. This is how it looks. Here is memory pin, termination resistors, and you actually can have the terminations with values 120 for this chip, this particular chip, memory chip. You can have 120, 60, 40, 30 and 20 ohm termination resistor. So when you simulate the memory, you need to select the correct termination, otherwise the simulation will be wrong. Again, select the termination, it's not so simple, because where I have my other data sheet, okay, I'm going here, see, the termination is actually changing when you read or when you write. These two tables, one is for write, one is for read, just gives you an idea. See, example with two slots, write to slot 1, slot 2, controller, that's FPGA or processor. In this case, this is FPGA, but it's same for processors. There is termination 50 ohms, which has to be switched on. If you write to slot 1, you need to switch on 120 ohm termination resistors on the data bus on the memory chips, plus some other signals, not only data bus. Yeah, dynamically, you see, and the other one is off. And it may be different for different situations. For the read, controller has 50 ohms and termination on the memory itself, it's off. See? So when you do simulation, you need to think about the particular case which you are simulating. I used HyperLynx for simulating the memories for two reasons. One reason is it supports multi-board simulation. It means if I want to simulate a board with SOD module, I can actually simulate my baseboard and the SOD module plugged into socket and simulate the signals through the socket. Basically what you do, you define properties of the connector of the slot, and you define first board, second board, and the HyperLynx automatically recognize what signals, what pins are connected, and it will make the simulation from the processor to the memory chip. This is actually what you see here. These are boards. This one I think is imported from Altium Designer actually, and this one is imported from Allegro file. So you can export directly the files which are supported by HyperLynx from the Altium Designer. And to show you another screenshot, this is from the process of setting up the simulation. This is the second reason why HyperLynx is very good. First one is the multi-board simulation. Second one, it supports directly DDR, DDR2, DDR3 simulations. So you just set up where are your memory pins, what is, in this case you can see, what are the terminations, what you want to use. Yeah, here is, you say I want to use these terminations on the controller for these signals when it is enabled and disabled. These are the terminations on the memory chips for different signals when it is enabled and when it is disabled. And the HyperLynx, based on all these settings, it automatically generates it automatically does all the tests, and it generates reports which tells you pass, fail, pass, 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 fail. The best is if it pass all the time. Yeah. To compare influence of different termination, I go back to the picture which we had here. You see, this simulates write for DDR3 DIMM memory, which uses 120 ohm termination. Looks like this. This one simulates write, again same memory, but the termination is 60 ohms instead of 120. See how it looks? This one is better. Okay? See, you can compare how big influence the setting of the termination has. So when you simulate the memories, be sure you simulate the right conditions, how the memory will be running. Everyone who was working hard last few weeks is going to have holiday. Now this week there will be not so much work because everything is going to be generated automatically. Okay, there is some work. So go to your project, create job file and create BOM in the job file. First generate just simple BOM, put there all the columns what you need to have, modify the template, change the logo, change the company name, the website, and generate the proper BOM. When you are happy with the BOM, go back to your schematic, create variant and unfit the components which should not be fitted for the variant. Go back, generate the BOM, select see if it's working correctly, and in the last step go back to your schematic, add the components like mounting holes, PCB, firmware. You can also create firmware symbol and describe what firmware should be loaded into what chip, U5, U6. And in this last step, generate the kind of BOM, press one click, which you don't have to modify, but have everything. The BOM will have everything what is needed to build your board. So you just take this BOM, you handle it someone, they order all the components, they order the PCB, and they send all the firmware files and everything to the assembly house, and they will be able to build the boards from the BOM without asking you any questions. This is your goal for this lesson. Next week we are going to speak about schematic checking and library checking, and this is going to be important lesson which is going to help you to produce, design boards which works at the first time. Yeah? So see you next week, and have a nice day. Bye bye.